And one thing that I forgot to write here, that would be message dot text, oh excuse me, message dot message underscore text. So here you can see that we have received an error with the gets message. So it says that gets function is too dangerous and it should not be used. So instead of gets we would use fgets, okay? And when we would use fgets, we have to it has actually 3 arguments. So we would pass here 500, then 500 is this length, okay? So that's what we have to pass, and then as the file stream we would pass standard input, okay? So that's it. Yes, we have done it. So now if we save it and if we go back and if we try to run our program again, let me just clear it. So if we hit enter, now you can see that there is no error, and now we can basically send the file, okay, send the message, excuse me. So now you can see that it says please write data to send. So we write here, hi, this is Linux hint and we are pleased to see you. Okay, so we hit enter and you can see that it tells we have sent, hi, this is Linux hint and we are pleased to see you. So now we go to the other terminal and we try to run here our other file as well, which is second.c, and we hit enter and you can see that there is no error in our second.c file as well, okay? So now what we would do, that we would try to run this binary file and we hit enter and you can see that it says the message, let me just, and now you can see that basically the message or data that we have received is, hi, this is Linux hint and we are pleased to see you. So you can see that whatever I have sent from here, it has been received in this terminal, okay, using the second file, okay? So in the first file I have sent the data, sent the message, and from the other file, from the second file, I have actually received it, okay? So now let's move on to the next topic. Okay, so the next topic is semaphores, alright? So the idea is that semaphores allow processes to synchronize their actions. This is useful when a process must gain exclusive access to some shared resource, such as region of shared memory. Okay, so we also have a shared memory as our next topic, but that we would discuss next in detail. Okay, so for now we'll stick to semaphores. So semaphores are created and operated upon in sets containing one or more semaphores. Each semaphore within a set is an integer whose value is always greater than or equal to 0. So it would never be in negative. The SEMOP or SEMOP is the function that we are going to use in our example that we would do in shortly in a short amount of time. So right here SEMOP. Okay, so this is the function that we would use. And this is a system call which basically allows the caller to add an integer to a semaphore. Okay, it also allows the user to subtract an integer from a semaphore or even wait for a semaphore to be equal to 0. Okay, so the last two of these operations may cause the caller to block, waiting to subtract and then waiting for it being 0. Okay, so these two operations it may cause the caller to block as well. Okay, a semaphore implementation is not required to initialize the members of a new semaphore set, so an application must initialize the set after creating it. So when any of the number of peer processes may try to create and initialize the semaphore, special care must be taken to avoid the race condition that results from the fact that these two steps are performed via separate system calls. Semaphores are allocated and operated upon in sets and can be increased and decreased by arbitrary amounts. This provides more functionality than is needed by most application. A common requirement is for individual binary semaphores which take on only the values 0 and 1. What we have to do, we have to use the libraries. Okay, we have to write here the libraries that we would be needing. So let me just remove these two. And the second library that we need is unistd.h, or the header file, you can say. So the third header file that we need is basically stdlib.h, and the fourth header file that we need, it is the string, okay, string.h. The fifth header file that we need is types.h. okay, so we write here include sys/types.h, and then we go to the next line where we write include, and then we write here sys/ipc.h, okay, inter-process communication. And then the last one which we have to have here is sys/sem.h. okay, so these are basically 7 libraries that we need, or 7 header files that we need. And right after having these header files, we need to define a key. Okay, so we write here define, and then we write here key, then we write here 0x1111. okay, so this is the key. So now what we have to do, that we have to have a union. I'll explain to you later after the code that what it is for, so and what exactly that is. So first of all, let me just write the code. So I'll just go like this. I'll put a semicolon here to end this, and in here I would write here int value, okay, and then I would write here struct, and then I will write here struct semid underscore ds static buff. Okay, then I put a semicolon again, then I write here unsigned. After that I write here short static and then array. Okay, after that what I'm gonna do, that I'm gonna basically create 2 structures. Okay, basically define 2 variables using structure. So I'd write here struct, and then I would write here sembuf, and then I would write here, let's say anything, a, you know, it's a kind of a variable name, so you can name it anything you like, and then you'd write here 0 comma -1 comma, and then you write here sem underscore undo. Okay, and basically the sem undo flag, it allows a process's semaphore operations to be automatically undone on process termination. Okay, this can be useful to avoid scenarios where a process accidentally terminates, leaving a semaphore in a state that causes other processes to block indefinitely, waiting for the semaphore's value to be changed by the terminated process. Okay, so after that put a semicolon here, and then we again write here struct sembuf, and then we write here, let's say b, and then we put an equal sign here, and after that we write here 0 plus 1 here, and then we write here sem undo as well. Okay, the same flag. After that we put a semicolon, and right after that we would come inside the main block, and inside the main block, first of all we are going to define an integer here, integer id equals, and then we write here sem get, and inside of that first of all we'd pass the argument as key 1, and then the permissions 666, let's say, and after that I'm gonna do the same thing as we have done previously. Okay, we'll write here create, and just before create I'll write underscore IPC. Okay, so after that what I'm gonna do, I'm gonna put here an if condition, to catch the error. So if the ID is less than 0, and right after that I would write here exit. Okay, and basically I would enclose it inside brackets, because now we have two statements. Okay, so something like this. And the next thing that we would do would be that we'd just simply write a few lines of code, something like this: union SEMUNSU SU dot value equals 1. Then we have SEMCTL function or method, and inside that we pass 4 arguments, and then we check if that is less than 0 or not. So then we write here p error, and inside of that we pass SEMCTL error. Okay, so here we can write SEMGET error as well, we can write here. Okay, and then you put a semicolon here to end the line, and then on the next line you can basically exit again. Okay, so you write here exit. So after that, because we don't want program to run further, so that's why we are exiting. So after this if statement, you'd write here integer process ID. Okay, and then you basically do a fork here. Okay, fork, and after that you basically use the srand function. Okay, and then you put here inside of that you put PID semicolon, and then you come to the next line, you check PID again. If that is less than 0, it means that we need to print an error. So we'll write here the error. Let me just have a body of the if statement, and let me just make a few spaces so that you can view the code clearly. So now what I would do, I would write here p error, and inside of that I would write, let's say, fork error didn't work or anything like that, and then I put a semicolon here, then I basically exit it. Okay, so once you have done that, now what you are supposed to do, that you are supposed to come here, and then you basically write here else if, and then inside of if you basically write PID. So it means that if there exists PID, then in that case, if PID is true, then in that case it would execute any further. Okay, so now what we would do, that inside here, inside else if, we'd write some code, and here we would use that function SEMOP or SEMOP. Alright, so first of all you have to have a character. Okay, character array, let's say character semaphore or SEM or SE, let's say. Okay, and here whatever alphabets you're gonna give, it's going to print that out. Okay, using semaphores. All right, so after few seconds, few milliseconds, as you would set the sleep time, those digits or those numbers or those alphabets would appear on your screen. Okay, so let's say we write here ABC,